I'm Greg LeBlanc, and I'm here at the Haas School with Erik Wilde, who is a former instructor at the Information School here at UC Berkeley, is also a web plumber.
Self-declared, yeah.
So Erik, you call yourself a data ecosystem gardener, and whether you're talking about being a plumber or a gardener, there's a lot that goes into the back end for any kind of data-oriented initiative or any data-driven company. But this is usually the kind of stuff that the business decision maker doesn't see. They enjoy the pretty garden and they love the running water.
Mostly the fruit,
yeah.
I think.
Right.
Or the vegetables.
But they often just sort of leave a lot of the big information architecture decisions to kind of IT folks and so forth. What does the business decision maker need to know about these major decisions, about these major infrastructure investments?
So in my mind, the most important thing is to keep in mind that in order to get good results out of your system, your garden, so to speak, in many cases it's important that you can experiment and change it and introduce new things and see how they work. So mostly my work focuses on trying to design, instead of designing systems, to have ecosystems where you can introduce new things easily, take out things without everything collapsing, and do that in an open way so that if you have somebody who basically tells you, hey, we can put in a nice garden for you, that you still make sure that if you can get somebody else sort of providing services that you might also find useful and valuable, that you can do that without having to completely switch providers or completely rip out your solution and build something new. So mostly it's about basically designing things that they are open and extensible and flexible and can adapt to changing circumstances.
Now, there's been a lot of talk about the move from kind of the data warehouse to the data lake. And I guess the advantages of that are that there's less of a need for complementarity between the hardware and the software, or that you can have all different kinds of data and all different kinds of programs running in this thing. But you've also talked about kind of the limitations of the data lake that arise precisely because it doesn't have any specific functionality. Could you talk a little bit about that?
Yeah, sure. So my main point there was that while the data lake definitely is a step forward from a data warehouse in terms of being more flexible, being more open, often being schema-less and allowing you to do things that beforehand really would have been much more expensive in terms of implementing new analysis you can run. It's still a very centralized solution where basically whoever is the solution provider for that data lake is very much in control of what you can do with your data and the kinds of analysis you can do. So it's still sort of a centralized thing where you really have not the flexibility to maybe play around with data in different ways, using different tool sets, and you kind of depend on that single provider or that single platform to really deliver all the solutions that you might want to have. So my main point there again is that if you have something that is more open, where instead of just having just one lake, you can actually say, well, I have the ability to play around with different lakes and sort of connect them and have information or insights flowing from one to the other so that I can play around with different tool sets and see how they work for me, and if they give me a better insights, maybe if I use a different kind of tool. So the ability to do that, I think, is something that is more powerful than just having one data lake. So that was my main point there I was trying to make, that a data lake basically is a system, it's not an ecosystem, right? So an ecosystem would be more the ability to combine different ones and pick the one that works best for you, or set up a combination that works best for you.
So introduce some more modularity to the way the data is stored.
Yes, so my main point is that you've seen in software engineering, you've seen that there was a big shift basically from software components working on the data directly to being very service driven. That people said, okay, it's just working on data is not really very open. Instead, what we want is have services that have well-defined interfaces that we can use and switch and change implementations. And I think in the data lake world, you could play around with similar ideas and say, instead of just having this one lake that everybody has to work on, you have services, and the services basically what give you the ability to put in additional things or to pull out things and to connect lakes in different ways. So making that step from pure data to services, I think, has happened in the software world, and I think it might also be something that increasingly happens in the data science and analytics world.
Great, thanks for your insight.
Thank you.